The ground just moved again in the Philippines, and this time the first number that came across every news feed was a magnitude 7.0. That number hit the wires at 12:13 in the afternoon on August 5th, 2026. And for anyone who remembers what happened on June 8th of this same year, those two digits, 7 and 0, are not just a number, they are a reminder. Because on June 8th, a magnitude 7.8 shook southern Mindanao, and it remains the strongest earthquake to strike the Philippines in roughly half a century. The ground cracked open under General Santos City. A Jollibee restaurant collapsed on camera. Bridges fractured. Coastal communities got a 1-meter tsunami warning that was not a drill. At least 106 people lost their lives. Over 1,300 were injured. More than 121,000 homes were damaged or completely destroyed. And the aftershocks never really stopped. By June 19th, Fivolks had already logged more than 8,500 of them. So when August 5th arrives and the bulletin says 7.0, nobody in that region reads that calmly. They feel it first and ask questions second. And the questions that came out of today's event are genuinely worth sitting with, because a few things about this earthquake are strange in ways that the standard bulletins do not fully explain. The first strange thing is the location error. When the automatic alert came in, it placed today's earthquake roughly 258 kilometers. That is about 160 miles, southeast of Sarangani, near the Talaud Islands. That location would put it practically inside Indonesian waters. Now, automatic solutions are always preliminary. The system is built to give you speed first and worry about precision second. That is not a flaw in the system, that is the design. But being 258 kilometers off from the actual epicenter is not a normal level of error. Most automatic solutions are not that far from where the final reviewed location lands. In this case, once enough seismic station data had been processed, the reviewed solution moved the epicenter dramatically, all the way northwest to a position roughly 37 kilometers southwest of Balut Island in the municipality of Sarangani in Davao Occidental. That is not a small correction. That is a completely different part of the ocean. It also changed the magnitude significantly. The initial 7.0 dropped down to 6.3 according to USGS and 6.4 according to FAVOS. A difference of 0.7 magnitude units sounds like a minor tweak, but it is not. Because magnitude is a logarithmic scale, that correction represents approximately 11 times less energy than what was initially estimated. 11 times. So the earthquake, that briefly looked like a major regional event independent of June's sequence, turned out, after full review, to appear directly connected to the ongoing deformation zone surrounding that June 8th rupture. Now, here is the second strange thing, and this one matters more for understanding what is actually happening beneath southern Mindanao right now. After the location and magnitude were revised, the focal mechanism came in. The focal mechanism is the seismological tool that tells you how the fault actually moved during the earthquake. It is often described visually as a beach ball because of how the compressional and extensional quadrants are plotted. And the pattern that beach ball shows tells you whether you are looking at a thrust fault, a strike slip fault, or a normal fault. Today's focal mechanism was described as unusually clean. The double couple percentage came in at 92%, which means this was a straightforward, simple rupture on a single fault plane with almost no volcanic component and no structural complexity worth arguing about. And what that clean mechanism showed was pure thrust motion. Both nodal planes, close to 90 degrees. Classic dip-slip reverse movement. The principal compression axis running at roughly 255 degrees, meaning maximum compression is oriented east-northeast to west-southwest. That compression direction is exactly what you would expect from the Celebes Sea seafloor subducting eastward beneath Mindanao, which is what the Cotabato Trench system does. So the mechanism is consistent, the compression direction is consistent, the fault geometry matches. This is subduction-related thrust activity. But here's the detail that makes today's earthquake genuinely interesting from a scientific standpoint, rather than just alarming from a human one. The moment tensor depth came in at 11.5 kilometers, roughly 7 miles. Compare that to June 8th's main shock, which Fivolks placed at 33 kilometers depth, and USGS placed at approximately 57 kilometers. Today's event is far shallower, and that shallowness places it up dip of the patch that ruptured on June 8th. That is important because it means this is not a re-rupture of the same fault surface that moved 2 months ago. Today's earthquake either ruptured the shallower near-trench portion of the subduction interface, or it ruptured what geologists call a splay thrust inside the accretionary wedge sitting above the main subduction surface. Both of those interpretations are physically consistent with stress transfer from the June main shock. When a large earthquake happens on a subduction zone, it does not just relieve stress in one clean location. It redistributes stress across the surrounding fault system, and some of that redistributed stress loads the shallower, up-dip structures that had not yet failed. That appears to be what happened today. The June 8th earthquake reached upward through the plate and triggered this shallower piece of the system. And that brings us to a point that deserves very clear language. Shallow thrust earthquakes near subduction trenches are, in the scientific literature, described with a word that I always make sure to say carefully, tsunami-genic, meaning they are disproportionately capable of generating tsunamis relative to their magnitude. A magnitude 6.4 event on a shallow thrust fault near a trench is a different situation than a magnitude 6.4 event on a deep inland strike-slip fault. The geometry of the fault, the shallow water column above it, and the vertical displacement of the seafloor during rupture all combined through the plate and triggered this shallower piece of the system. And that brings us to a point that deserves very clear language. Shallow thrust earthquakes near subduction trenches are, in the scientific literature, described with a word that I always make sure to say carefully, tsunami-genic, meaning they are disproportionately capable of generating tsunamis relative to their magnitude. A magnitude 6.4 event on a shallow thrust fault near a trench is a different situation than a magnitude 6.4 event on a deep inland strike-slip fault. The geometry of the fault, the shallow water column above it, and the vertical displacement of the seafloor during rupture all combine to give shallow, trench-adjacent thrust earthquakes an outsized ability to move water. This is exactly why, when today's initial bulletin showed a 7.0, a tsunami evaluation was immediately triggered. The automatic system was not being overcautious. It was doing exactly what it is supposed to do when the fault geometry matches the profile of a historically tsunami-genic setting. The June 8th event itself produced tsunami waves of approximately 1 meter along the coasts of Kiamba and Masim in Sarangani province. 1 meter does not sound like much until you understand that water, moving at tsunami velocities, carries debris, sweeps people off their feet, pushes them against walls, pulls them into the current, and can be lethal at heights well below 1 meter. The June event put real tsunami water on real coastlines. Today's event, at its reviewed magnitude, does not approach that threshold practically. But the moment the fault type and geometry are involved, the evaluation cannot be skipped. There's also a clarification worth making here because this specific area has a naming issue that trips people up constantly, including in the initial reporting today. There are two different Saranganis involved in this story. There is Sarangani the province, which sits next to General Santos City and is where the worst devastation from June concentrated. That is the Sarangani where Glan was hit hardest, where 32 people alone were lost in that one municipality, where rescue teams were still pulling people out of rubble days after June 8th. And there is Sarangani, the island municipality located in Davao Occidental, which is roughly 100 kilometers, about 62 miles further south. Today's earthquake was near the island, not the province. The two locations share a name. They do not share a geography. That distinction matters because when the headline says Sarangani, readers who have been following June's events think of the province, the buildings that fell, the people who died. What happened today is geologically connected to that same broader system, but it is a different piece of coastline and a different population center dealing with different local conditions. The shaking today was real and it was felt widely. 5 volts recorded intensity 5, described as strong shaking in Glan in Sarangani province. Intensity 4, moderately strong in Kiamba and General Santos City. Intensity 3 in several other municipalities. USGS estimated maximum shaking around modified Mercalli scale 6 in the area immediately around the epicenter, which means at that level everyone in the area feels it. Objects fall from shelves, and poorly constructed buildings are at risk of damage. Under normal circumstances, a magnitude 6.4 at that intensity level might cause limited damage. But these are not normal circumstances. The structures across southern Mindanao right now are not starting from a healthy baseline. They are starting from a baseline that was already cracked and weakened and in many cases already classified as compromised after June. A masonry building that survived June 8th with cracks in its load-bearing walls does not respond to today's shaking the same way it would have responded on June 7th. The cumulative damage matters. The structural weakening matters. A magnitude 6.4 landing on buildings that are already fractured is a fundamentally different event than the same magnitude landing on intact construction. 5-Volk's official position was that no damage is expected. That assessment assumes structures are in good standing condition. Across this specific region, after 2 months of ongoing aftershocks on top of the June main shock, that assumption deserves scrutiny. This is also a good moment to understand the energy accounting, because the way people talk about aftershocks is often misleading. Today's earthquake released roughly 1/150th of the energy that the June 8th main shock released. Stated differently, you would need approximately 150 earthquakes of today's size to equal what June 8th put out in energy. That sounds reassuring until you understand what it actually means for the stress remaining in the system. Today's event relieved almost nothing. It is a rounding error on the total energy budget that is still stored inside the Cotabato trench system. The June 8th earthquake did not exhaust the stress in this region. It redistributed it, and the redistribution is still ongoing. The aftershock sequence has been running for nearly 2 months. It is not winding down the way a typical sequence winds down. As of June 19th, the count already exceeded 8,500, including 3 events above magnitude 6.0 and a largest aftershock of 6.5. A 6.5 aftershock in any sequence is not a footnote. A 6.5 is a major earthquake in its own right that would be front-page news if it occurred anywhere that had not just experienced a 7.8. To understand why this region behaves this way, you need to understand what is actually happening geologically beneath southern Mindanao, because this is not a location that has seismic activity because of bad luck or random geological misfortune. Mindanao sits at the intersection of 2 colliding subduction systems. To the east, trench that sits roughly 70 to 100 kilometers long between the June 2026 rupture to the south and a magnitude 7.5 event from late 2023 to the north. That section of the trench, based on available records, has not ruptured since at least 1918. It has been accumulating stress for over a century. Squeezed between 2 ruptures, it has not yet joined. The June 8th earthquake, rather than relieving the stress in that gap, may actually have loaded it further through the static stress transfer mechanism. When one part of a fault ruptures, the stress it releases has to go somewhere. If the neighboring locked section of the same trench was already near its failure threshold, that additional transferred stress can bring it closer to breaking. Researchers at Temblor who analyzed the June 8th rupture pattern specifically flagged this 100-kilometer central section as a segment of concern. That gap is still sitting there. Today's earthquake was at the southern end of the aftershock zone, not in that central gap. Today did not trigger the scenario the seismologists are watching for, but today did not close it either. It is also worth being clear about what today's earthquake was not caused by. The 2 most famous named faults in Mindanao are the Mindanao Fault and the Philippine Fault. Both are left lateral strike-slip structures, meaning they move horizontally past each other rather than vertically over each other. A strike-slip fault does not produce a thrust beach ball. The focal mechanism today was unambiguously thrust, not strike-slip. So neither the Mindanao Fault nor the Philippine Fault is the candidate for today's earthquake. The geometry simply does not match. The compression direction, the fault orientation, the dip-slip reverse motion, all of it points consistently to the Cotabato subduction system. That matters because it means this earthquake is part of the same prolonged system-wide adjustment that has been running since June 8th, not a separate fault being triggered into a new and independent sequence. The seismological signal that everyone watching this region is actually looking for is not a large magnitude number. A 6.4 or even a 6.5 fits comfortably within the expected behavior of a sequence following a 7.8 main shock. Large aftershocks are normal. The signal that would be genuinely concerning is not the size of individual events, but the migration pattern. If the aftershocks begin moving geographically northward, up toward that unruptured central segment of the Cotabato Trench, that migration would be the indicator that stress is propagating toward the locked section. Migration, not magnitude, is the thing to watch. A single 6.4 in the southern part of the aftershock zone, as happened today, does not represent that migration. It represents ongoing deformation in the same zone that has been active since June. But the monitoring has to continue, and the data has to be read carefully because the system is demonstrating, event by event over 2 months, that it is not finished adjusting. The broader historical context for this region should put today's earthquake into proper perspective without minimizing what is still a major seismic event. In the past decade alone, 17 earthquakes of magnitude 6.5 or larger have struck this general region, 7 of them above magnitude 7.0. This is one of the most seismically active zones in one of the most seismically active countries on Earth. The Philippines sits on the Pacific Ring of Fire. It is surrounded by active subduction zones on multiple sides. Significant earthquakes are not anomalies here. They are the operating condition of the crust beneath these islands. The question is never whether the system will produce earthquakes. The question is which fault, at what depth, at what magnitude, with what geometry, and what stress that particular event transfers to the surrounding structures. Today's event, by those measures, is most likely another chapter in the ongoing June aftershock sequence. A significant chapter, because 6.4 is major by any global standard, but a chapter within a story that began on June 8th and has not yet concluded. What the next several days will tell researchers watching this data is whether the current level of activity continues to decay as expected, or whether today's thrust event has done something interesting to the stress field in the shallower portions of the subduction zone. The shallow near-trench splay structures that may have hosted today's rupture are not well mapped. They are part of the accretionary wedge, which is geologically complex and not as well characterized as the main trench interface. Future events in the same shallow depth range and with similar thrust mechanisms would be informative about whether today was an isolated adjustment or the beginning of a new phase of activity in the updip portion of the system. For the communities living across southern Mindanao right now, the significance of today's earthquake is not primarily geological. It is the fact that the ground has moved again. Buildings that were cracked in June and have been living through thousands of aftershocks since then shook again today. People who have been sleeping in evacuation centers or in relatives' homes because their own houses are structurally compromised felt the ground move beneath them again at 12:13 in the afternoon. The 106 people who died in June, the 1,316 who were injured, the more than 121,000 whose homes were damaged or destroyed, their lives are still in the middle of a slow and difficult recovery process. Every significant aftershock interrupts that recovery. It keeps people out of damaged buildings that need to be inspected again. It delays reconstruction assessments. It sustains the psychological burden of living in an area where the ground has proven it can move at any time with very little warning. The human cost of the June 8th earthquake does not end with the emergency response phase. It continues through every aftershock, every building assessment, every family still waiting to go home. There's one more dimension to today's event that deserves attention, and it connects directly to the question of what the Cotabato Trench is capable of producing over longer time horizons. This system has already demonstrated in the historical record what its upper range looks like. The 1918 magnitude 8.3 is not just a data point. It represents the kind of rupture that the Cotabato Trench geometry can physically generate when sufficient stress accumulates across a long enough locked section. The 1976 Moro Gulf earthquake, magnitude 8.1, generated a tsunami that was not 1 meter. It was catastrophic. It killed thousands of people. The reason the 1976 event is the reference point that seismologists keep returning to when they discuss the current sequence is that it provides a real historical example of what this specific fault system does when it releases energy at its upper capacity. The 2026 main shock at magnitude 7.8 was the largest Philippine earthquake in roughly 50 years. It was very close to the energy level of those historical events, and yet it did not rupture the central gap. The central gap remains locked. It was there before June 8th. It is there right now on August 5th, after today's 6.4, and it will be there tomorrow. That is the geological reality underneath the relief that today did not become something worse. There's also a practical dimension to the shallow depth of today's event that goes beyond the tsunami discussion. Shallow earthquakes, meaning events above roughly 20 kilometers depth, radiate their energy more efficiently to the surface than deeper events do. A 6.4 at 11.5 kilometers depth shakes the surface more intensely than a 6.4 at 50 kilometers would, because there is less rock to absorb and scatter the seismic waves before they reach the ground. This is why 5-Volks recorded intensity 5 shaking in Glan, even though the epicenter was tens of kilometers away, and the magnitude was not extreme. Shallow earthquakes hit harder at the surface per unit of energy than deep ones do. This matters enormously for the communities across Sarangani, General Santos, and the surrounding municipalities, because the buildings they are living in right now are already absorbing each of these shallow, efficiently transmitted shaking events on top of everything they absorbed since June. Structural engineers use the concept of accumulated damage when assessing buildings after an earthquake sequence. A building that has been through thousands of aftershocks, even small ones, has been through thousands of cycles of stress and strain on its joints, its connections, its load-bearing elements. Cracks that were hairline in June may now be wider. Steel reinforcement that was intact in June may have experienced fatigue. Masonry that was stable in June may have shifted. The physical condition of the building stock across this region needs to be assessed not on the basis of what it looked like after June 8th, but on the basis of what 2 months of ongoing seismic loading has done to it since. What today confirms, when you take the location, the mechanism, the depth, and the magnitude all together, is that the June 8th rupture was not a discrete event with a clean ending. It was the beginning of a prolonged adjustment of the crust in southern Mindanao that is still actively underway nearly 2 months later. The Cotabato Trench continues to subduct. The stress continues to redistribute. The aftershock zone continues to produce earthquakes. And somewhere north of today's epicenter, a section of that trench that has not ruptured in over 100 years continues to hold. The system is still talking. The data is being read, and the monitoring continues. Script 8500 aftershocks. Later, the Philippines just moved again. Word count, 4,000 words. It is worth saying something directly about how people process ongoing earthquake sequences psychologically, because the human response to what is happening in southern Mindanao right now is not well served by either extreme. The response that says today was just a normal aftershock and everything is fine misses the cumulative physical and psychological toll that months of ground motion place on communities that are simultaneously trying to rebuild. And the response that treats every event as a sign that something catastrophic is immediately imminent creates a state of chronic alarm that is unsustainable and counterproductive. The honest position sits between those two. Today's earthquake was a significant seismic event. It is most likely an aftershock of June 8th. It relieved almost nothing in terms of the stored stress in the broader system. The central unruptured segment of the Cotabato Trench remains a legitimate long-term concern. And the communities of southern Mindanao are dealing with a situation that is not over, will not be over quickly, and deserves sustained attention from authorities, engineers, and emergency management professionals, rather than a slow drift back toward normalcy that the geology does not currently support. What every additional event in this sequence contributes is another piece of information about how this particular fault system behaves following a major rupture. The June 8th main shock occurred on a fault system whose exact rupture geometry was genuinely ambiguous in the immediate aftermath. 5 Volks themselves acknowledged that the earthquake may have ruptured the northern Sangihe Trench, the southern Cotabato Trench, or some combination of both. That is not a failure of science. It reflects genuine geological complexity where 2 subduction systems interact. Today's earthquake, with its clean thrust mechanism and east-dipping geometry, adds a data point that supports the Cotabato Trench interpretation for this part of the aftershock zone. Every event in a well-recorded sequence makes the subsurface picture a little clearer, and understanding that picture accurately is the foundation for hazard assessments that determine where people rebuild, how they build, and what preparedness systems communities maintain for the decades ahead. Today is one more data point in that longer story. The ground moved, the instruments recorded it, the analysis is ongoing, and the people of southern Mindanao go through another afternoon, another set of alerts, another quiet count of who is accounted for and who is not yet home.